Hello, my name is Sean Yarder, and this is my presentation over Chapter 6 of the Designing Geodatabases textbook, Surveying Federal Lands. The organization in charge of mapping out federally owned lands in the United States is the Bureau of Land Management. The BLM uses the Public Land Survey System as a basis for its maps. The National Integrated Land System is the GIS environment where the BLM stores and maintains its data. Before the Bureau of Land Management was established, the General Land Office was in charge of mapping the newly acquired lands in the United States. This process began in the late 1700s and into the early 1800s. In addition to storing maps of federally owned lands, the Bureau of Land Management is also responsible for protecting the environment, protecting endangered species, and also strategizing for new energy resources. I would like to go over some of the data maintained by the Bureau of Land Management. The different data maintained by the BLM helps its users create or modify parcel data or assists its surveyors in gathering correct information for creating survey plats. The basis of BLM's maps is the Township Polygons feature class. Next, data for property corner points and monuments help establish accurate coordinates for properties. Next, we have the case data. A case can be considered a survey request. Survey requests can be triggered by a land title dispute, land conveyance, or to correct a mistake of property boundaries, among other reasons. The right polygon layer shows where the federal government reserves rights over a particular area. The federal government might reserve an area for a canal, a national park, or some other public use. The segregation polygon shows areas where the federal government restricts the public from using certain land. For example, a certain area may be prohibited from use for habitat restoration. There are three different polygon feature classes for the townships in the PLSS. The first feature class is for the PLSS First Division. The First Division represents the largest division of the township and range grid. The PLSS First Division shows the polygons that contain 640 acres. This is an example of a township and range monument that shows the corner of this particular range and section. The PLSS Second Division feature class represents the second division of the township polygons. The second division polygons are 1/4 of the first division polygons and contain 160 acres each. Finally, we have the third division polygons, which represents the smallest division of the PLSS township and range polygons. These polygons are smaller than 160 acres and become smaller as more divisions occur. The township and range grid is the basis of the public land survey system. Township and range is a rectangular grid used in 32 different states. Each of these states has a prime meridian and a baseline. Each township is 6 square miles and divided into 36 sections, and each section is 1 square mile or 640 acres. In the image on the left, you can see the state of Arizona with the prime meridian and baseline. In the larger scale map in the center, you can see the different township and range numbers. In the image on the right, you can see the numbering of the 36 sections. Notice how the numbering begins at the northeast corner of each section. The bottom right image shows the correct way to number township and range. This is similar to an XY coordinate grid. If you begin at the origin, or the point where the prime meridian intersects the baseline, and count northward, you count up numerically for the township numbers, and the range numbers count east to west. This is an example of the subdivision plat that calls out the township and range. This particular plat of Copper Hills is located in township number 115, range number 24. Here's another example of the subdivision plat that includes the township and range information in the legal description of the plat. This particular plat is located in the southwest quarter of Section 8, Township number 7 North, range number 7 West. This is an example of a township and range description where the third division polygon would come into play. The area shown in red in this diagram would be described as the northwest quarter of the southeast quarter of the northwest quarter of a section. This description can sound complicated, but in order to correctly describe an area, you should start by describing the smallest division first and work your way up to the largest division of the township and range section. Here's another example of a subdivision plat that has township and range information. This plat indicates the location of a monument at the corner of the subdivision. This monument marks the southeast corner of the north half of the northeast quarter of this particular section. The bottom right diagram shows where this survey monument would be located. The NILS is divided into 4 separate applications. And on this diagram on the right, you can see the conceptual module for the NILS. At the bottom of this model is the survey fabric, which contains raw survey data collected in the field. The raw survey data is linked to the legal description fabric. The legal description fabric is used to create accurate parcel information that can be used in the top layer of the model, the parcel fabric layer, which is used as a model for creating maps of the area of interest. The first module of the NILS, Survey Management, assists surveyors in managing data collected in the field. This is also a method for exporting data from various surveying equipment into the database. For example, a GPS or a theodolite may be used as the survey equipment. The Measurement Management module consists of a set of tools for surveyors to collect and verify data from plats. The Measurement Management module is part of a seamless measurement network used to create the legal description fabric. The Parcel Management module is a GIS application where users can create and update parcel data. Users may be interested in a particular parcel when a new survey request is received. The final module is the GeoCommunicator. This is a web portal with an interactive map. This allows users to research parcel data for federally owned lands. The NILS consists of a geodatabase that has 2 different feature datasets. The first feature dataset is focused on surveying and maintaining accurate data. One of the feature classes that serves as the basis for this geodatabase is the PLSS Township feature class. The naming convention for this and other feature classes used by the BLM is the state abbreviation followed by the description of the layer. For example, the township polygon layer might be named TX for Texas _ PLSS Township. There are topology rules used to maintain the accuracy of the township polygons. The township polygons must not overlap and must not have gaps. Another feature class used by the NILS is the corner feature class. Again, a corner represents the property corner boundary of the federally owned land. There may be monuments at the corners. Therefore, the corner has a relationship with the monument layer. A corner may have multiple monuments, because at times a monument can become disturbed or destroyed, or a monument may be placed in the incorrect location. Therefore, the corner feature class has a one-to-many relationship with the monument feature class. Another feature class used by the NILS is the case feature class. Again, the cases is an example of one survey request, which can be triggered by a title conveyance, a dispute over land ownership, or to correct a mistaken property description. The case feature class has relationships with several other feature classes. Some of the relationship classes include case to right, case to segregation, and land status to case. The case feature class also has a relationship with another feature class named label line. This allows the cases to be labeled neatly, where the label annotation is always placed on the bottommost line of a particular parcel. The geodatabase contains various coded value domains to be used in conjunction with all the feature classes. A coded value domain allows for better and more accurate input of data as opposed to manually inputting the data. This particular coded value domain is for the managing agency. The Bureau of Land Management and several other agencies may be in charge of a certain land. The geodatabase also contains some tables that have no spatial reference. The tables shown here are a few examples, like a customer or a remark or comment that can be added to a specific case. Although these tables have no spatial reference, they can still be linked through a relationship to a certain case ID. The NILS implements various topology rules to protect the accuracy of the parcels. Here you can see the feature classes that participate in topology along with their corresponding ranks. Near the top of the list is the measured coordinate and monument feature classes. These feature classes are based on survey data gathered in the field and can be trusted for accuracy over other layers. Other layers that participate in feature class in topology include the PLSS township layers. This is the homepage of the GeoCommunicator website maintained by the BLM. The GeoCommunicator website allows users to view an interactive map and find information on different sections in the 32 states that use PLSS. Here's an example of the interactive map. You can see the divisions of the township and ranges in this area. If you zoom in closer, you can find examples of cases for this map. This is an example of identifying a feature with the GeoCommunicator web portal. Here you can see a polygon for a rangeland. This rangeland is located in Colorado at Douglas Mountain. The animal type attribute shows as horse. And another useful way to utilize the GeoCommunicator website is to search for different areas where mining claims exist. You can zoom to certain areas to find which areas fall under the BLM's jurisdiction. You might use this website to prospect for certain areas where precious minerals or oil and gas can be harvested successfully. While manually using the interactive map to zoom to areas and identify features is one method of finding information in the Geocommunicator web portal, there are also options for searching for a particular type of data. There are various functions including energy search, record search, or searching for mining claims. These buttons lead to a dialog box that can allow you to search for particular names of mining or rangelands. The practices followed by the Bureau of Land Management for surveying federal lands can be compared to the methods of smaller jurisdictions. For example, a county government also keeps track of parcel information the same way the federal government does. The county governments typically offer an appraisal district map that can be accessed online, where users can view parcels, find the owners of parcels, and find other information such as tax value, while the federal government offers the Geocommunicator web portal for finding information on federally owned lands. In order to support both of these geodatabases, both the county government and the federal government have a parcel layer. This parcel layer also includes a corners and monuments layer, which is used to maintain the accurate location for property corners. Both county government and federal government also keep track of any restrictions that are linked to a certain property, or parts of properties that are restricted to a certain use. In conclusion, the purpose of the Bureau of Land Management and the NILS is to store ownership data for federal lands. The NILS utilizes the Public Land Survey System as its main base map. The Public Land Survey System was established in the 1700s and early 1800s as a method to map out vacant lands in the United States. Township and range can accurately describe a parcel location. The BLM handles their survey requests as individual cases. A case can be triggered by a land title dispute, a title conveyance, which can be conveyed to or from the government, or to correct mistakes on existing parcels. The BLM also offers a Geocommunicator website where users can find information on federally owned lands. Thank you for listening to this presentation on Chapter 6 of the Designing Geodatabases textbook.